We are doing Chapter 3's Bivariate Data Project, Task 7, Finding Your Best Prediction Model. So, today we're actually going to look a little bit back at how to find all of your regression models from Task 6, and we're going to look ahead at finding your best of the overall data models. Now, I would like to remind you that every time you identify a new subgroup, you do need to do at least some analysis for that, but you do not need to create the residual plots for anything except for your whole group. In order to speed things up, I have actually loaded all of my data, let's see, from row 2 down to row 82. So I have about 81 data points. All variously seniors, juniors, riding in a car, driving in a car, bus, walk, or bike. So all of my data is now ready to go in my calculator. I've already done a little bit of head work on this. I've created my linear residuals, but I also have taken away my linear regression model just in case we need to see what that looks like. So to get your linear regression, again, you hit Stat, Calc, and then option 4 is your linear regression. And I'm running this just on my L1 and L2. You might see that I've got some of my subgroup data already set. So it looks like the linear regression model here is something like y hat equals 1.054x plus 7.807 with an r squared value of 0.067, which is not all that great, but r squared is not the only way that we determine what our best measure of center or what our best regression equation is going to be. Now, like I said, I've already kind of created the residuals, so I could look at this in my calculator by hitting second stat. If you've already got a plot set as your residuals, you can just do that. Or again, for the Y list, you hit second stat to get to your list of lists and just scroll through until you find your residual list. And then you can quit out of here and zoom 9, and this should kind of be what this looks like. And it looks like that's not quite the same graph. That's a little bit weird. Well, maybe I need to change something in how this is run. Let's see, what if I do it like this? No. Vertically. Okay. Switch rows and columns? No. Well, I will figure out how to get this proper picture in here, but at the very least, you know what? I can take a screenshot, Command-Shift-3, or even better, Command-Shift-4. Command-Shift-4 on a Mac lets you take a screenshot of just a portion. So now I should actually have a picture of my residual plot that I can use instead of this one that seems to be wrong. We'll still try to get a residual plot in the graph, but that's okay. But it looks like we do not really have, maybe we do have a pattern. It does, but it does seem kind of randomly scattered. So residual plot has no pattern. It might be good. Other things to check: if x equals 0, what happens? And that means that if a person lives across the street, what would happen? So if x equals 0, then y is 7.807, which means for me, a person would be late 7 or 8 times in a semester, which sounds somewhat reasonable. Maybe it's our best model, maybe not. We need to check against other things as well. So now I'm going to run a new regression, StatCalc option 0 for an exponential regression. And something special happens here. Because I had some y values that were 0, I get a domain error. So that means that I can't actually get an exponential regression here, which is fine. It just means that it's not going to be the best measure of center for me anyway. So cannot find this equation. And the mathematical reason for that is this would force me to take the logarithm of 0. So if you ever get a domain error from your exponential regression, just make sure that you say that this would force you to take the logarithm of 0. So this can't be our best equation since there is no equation. But we still need to check our quadratic, so let me quit out of that. So stat, calc, and then option 5 is a quadratic regression. Let's see if this is better than the linear regression. And then we'll try to get another residual plot if we need. So this is looking a little bit better. Our quadratic regression is y hat equals 0.214x squared, there we go, minus 2.924x plus 16.148. Okay, with an r squared value of 0.204, which is much stronger. But if we have a quadratic 0, then y would equal 16.148. Let's also check the residual plot by, again, I've already got my residual plot set up in option 1 here. So we'll just zoom 9 on a new one. And that is kind of just as random as before. Do I have... these are all turned off? Okay. So just as random. No pattern, which is good. No pattern means it might be useful. However, 16.148 as a y value doesn't make a ton of sense, because the person would be late or tardy 16 times if they lived right across the street, which is less reasonable than the linear model. So even though the quadratic model has a higher r squared, our linear model is going to be the best. So I'm going to give myself a little mark that because there's no pattern to the residual plot, and the result of a very, very small number seems more like what we would expect if somebody lived right across the school. Maybe they would be late or absent a few times, but not 16. 16 is kind of a big number for that. Even though the r squared is smaller than the quadratic, it looks like our best equation is the linear regression. So we would need to then... here, we can also play with looking at the quadratic residuals if you would like. You can always create an equation by hitting equals and then parentheses. And what we can do is we can take our exponential regression equation. Here, let me rerun it just so that I've got it on the screen right here. So we're going to have 0.214 times D2 is where my my first x value is, and that's going to be squared. I'm not exactly sure if this is going to square properly, so I'm just going to say times itself. minus 2.924 times that x value again, and then plus 16.148. Close my parentheses, and when I hit enter, that has created the residual value just for this particular set of x values. I will accept the autofill. If they don't have the autofill, you can always grab the little dot in the bottom right hand corner and drag it down, and that will also help you autofill. So to create a residual plot, we need to select some x values, and you might need to hold Control to click some y values. And we will insert, let's insert x values. On a Mac, it's Command click to grab both columns. Yeah, I'm gonna have to hide my calculator for a second so I can get my where did my top row go? Well, it's a good thing I already took a photo of that, because I will use that photo later to pick my best residual, or I will show my residuals using that photo in a little bit. Oh, and it looks like that is messing with my values in my graph. There we go. So there's my tardies and absences. Again, that's a little bit better. Don't know what happened to my graph there. Oh, I know what happened. There's my D. Okay, that's looking better. That's my plot as it should have been. So again, our best equation right now is the linear regression. So going back to my project here, scrolling down to my results section, you might also see that I put in the QR code that I was missing before. I also put in the scatter plot here. So the linear regression for all of my responses was y hat equals 1.054x plus 7.807 with an r-squared value of 0.607. This was our best available equation. Not necessarily the best, because again, the r-squared value is pretty small. It's not super accurate, but it was the best that we have, since the y-intercept was the closest to our expected value of 0. That was kind of the tiebreaker. The exponential regression was not able to be found, since we would have had to take a logarithm of 0. So again, if that happens, you can just use that sentence if you would like. The quadratic regression for our responses was y hat equals 0.241x squared minus 2.924x plus 16.148 with an r-squared value of 0.204, just stating what the results were. The residual plot for the linear regression was given below. Again, this is what my plot originally looked like. I might need to go back and change it to the photo that I've taken. I should also add the residual plot for the quadratic regression. Equation for all responses is given below. And then a little note to myself to insert graph as soon as I can. Now, remember, again, anytime you have a subgroup that you identify, you need to analyze that subgroup the same way you did the entire group. So I actually have a whole bunch of subgroups. First off, what year are you in high school? I can now, since this is in a table, I can sort the entire table, and this changes not just it keeps all of my rows in order. So this junior originally went with this 5 and this 8, and this person still drives in a car. So you might notice that I've got both juniors and seniors. And then how do I get to school most days? Again, let's sort this from A to Z so I can look at my data differently. I have some people who bike, some people who take the bus, some people who drive in a car, and some people who ride in a car, and some people who walk. So I have 8 extra groups that I need to look at. This is why you probably don't want to ask too many demographic questions. But I do have all of those groups with regression equations set up. So juniors, turns out for my juniors who answered, the quadratic regression was best. For my seniors, the linear regression was best. For people who bike, the quadratic regression was best. People who take the bus, we actually could get an exponential regression from them. And their exponential regression was the best predictor there. Of the people who drive, again, the quadratic ended up being the best that we had available. The people who ride to get to school, also the quadratic was the best we have available. And then finally, the people who walk, the linear regression, again, was the best one that we have. So you do need to state for every single subgroup like that. You know, if you asked about juniors and seniors, you need 2 more equations. If you asked freshmen, sophomores, juniors, and seniors, you need 4 more equations. And again, if you also gave other options in a second question, like how do you get to school, you need another set of equations for each of those. I will not make you do residual plots for all of them, but I have done those for myself. So again, once you have all of those, you still need to basically copy and paste most of the sentences from before, but now instead of looking at all data, now I'm looking at juniors and their equation with an R-squared value of 0.044. Another reason that I like having these in a spreadsheet is because then I can copy from the spreadsheet the entire equation pretty easily. Here, let's stop going back to that. And that was for my walking data. So the linear model was, let's pretend I copied and pasted. I could paste here. Let's pretend that I left a spot. People who walk was Command V. I can paste right there from my spreadsheet. And most of the verbiage is the same. I just changed the position about which equation was best. Depending on what was best. So again, the linear was best for the students who walk. The exponential was the best for students who ride in a car. So I'm going to go back and replace this picture and the other quadratic regression picture as soon as I can, and you should be ready to roll on this project.